Welcome. In this video lecture, I am going to cover k-means clustering algorithm. So here k is basically indicating the number of clusters. So which means on a given number of data points, how many number of small groups you want to divide those data points, or how many number of clusters or the groups in which you want to divide those data points. Using what method? Using either you can apply the mean method, then would be known as k-means clustering, or whether you want to divide it using median method, then it would be known as k-medians clustering method. But right now we are talking about k-means clustering algorithm. So we do have certain method in which we can use to decide how many number of cluster we should develop, which mean how many groups we should decide to divide those data points. But right now, what I am going to do is we are going to randomly pick the number of clusters. Like let's say if I have 10 data points, we decided that we are going to divide those data points into the two cluster or three clusters. So that means so we have to initially tell how many number of groups or the clusters you want to divide your data points. So the algorithm is, first of all, we need to select the k, which is the number of clusters, or you can say the number of groups in which you want to divide your data points. Then the next thing is we need to decide based on the number of cluster for every cluster, what would be the center point, which means what would be the initial center point. So initially we will take any k number of data points. So k number of data points mean, because we decided, let's say k are the two clusters, so we are initially going to select any two k data points would be considered as the clusters. So one point is going to be considered as cluster 1 center point, another point is going to be considered as cluster center point of the cluster 2, and so on, right? So it could be the data points within the given data points, or it could be outside the data points. So it's up to you that you can take initially any data points as a center point. Okay, so once we decided the k and we decided the center point, then what we are going to do is we are going to calculate the distance of every data point to the center point. Okay, so in order to calculate the distance from every point to the center point, so there are different methods to calculate the distance between the every particular data point to the center point. Either you can apply the Euclidean distance, or either you can use the Manhattan distance method. Okay, so but what I am going to do is I am going to apply the Euclidean distance method. So what is the that method or the formula to calculate the distance, we talk about in a minute. Okay, so once we have calculated the distance from every data point to the center point, then we are going to assign that particular data point to whether it is going to be the part of the cluster 1 or the cluster 2 or the cluster 3, okay, and so on. So based on what? Based on the smaller distance. Okay, so we will compare the data point and the center point. Okay, the data point having the smaller distance to the particular center point, so that means that data point is belong to that particular cluster. Okay, so as I mentioned that, so we are grouping based on the minimum distance. Okay, so when we are going to stop this algorithm, when we will say during the iteration no data point is moving its or leaving its particular cluster, then we will stop the algorithm. So let's see with the help of example, then we will get the clear understanding. Okay, so right now we are saying that we have decided that we have to divide our data point into the two clusters. Okay, and these are the six data points we have. So we want to divide these six data points into the two clusters, and the features we have, or you can say the key variables we have, that is 2, x and y. Okay, and we have six data points. Okay, and right now the initial centers, we decided that this fifth data point is going to be considered as first center point, which means that is the cluster 1 center point, or the sixth point, that is cluster 2's center point. Okay, so these are the two cluster, or you can say two groups, and these are the initial center point we are considering, right? So we have plot these data points. So that means this is x variable, this is y variable. Now we want to decide, okay, which data point is going to be part of the cluster. Either this is going to be the cluster and this is going to be the cluster, or maybe these four data points are going to be in one cluster, these two data points are going to be another cluster. So let's see how we can find this one. So we already decided that we want to develop two means clustering. Okay, so two means clustering means the k is equal to 2. That means we want to divide these six data points into the two clusters. Okay, so what was the first step? So this is an iterative approach, mean that is the algorithm. Okay, we have the two center points. So this is cluster 1 center point, this is cluster 2 center point, this is the x, y, x, y. So we are going to use the Euclidean distance formula. So what was the Euclidean distance formula? From every particular data point, we are going to find out the distance to every cluster center point. So this is cluster 1. So what is the Euclidean distance formula? So the value of x minus the center point value of x. So this is 7 minus 9, and we will take the square. Okay, so this is 7 minus 9 and square. So this is actually what we are doing, this 7 minus 9 square plus 3 minus 7 square. Okay, and then taking the square root. So this is basically x1 minus x2 square. Okay, and then we are saying y1 minus y2 square, and then taking the square root. So this is that basically Euclidean distance formula. Similarly, we are going to find out, so this is the answer of the first one. Okay, the distance of this point to this point is equal to this one. Now we are going to calculate the distance from point 1 to second center point, which is this data point. Okay, so that's why we are doing 7 minus 6 square. Okay, and then 3 minus 8 square. Okay, and taking the square root, that is this one. Similarly, we are going to calculate the distance from the point number 2 to center point number 1 and 2. So that means point 2 to point 5, that is basically cluster 1's center point. Okay, that is this one, which is 4 minus 9 square plus 5 minus 7 square, taking the square root. This is the value. Then 4 minus 6 square, then 5 minus 8 whole square, taking the square root, that is this one. Similarly, we are going to do with point number 3 with 5 and 6. Similarly, we will do from point number 4 to 5 and 6. Okay, now we are going to again write down those data points. Okay, so these were the center point. Now we are going to decide which data point is going to lie which cluster, whether the cluster 1 or the cluster. So the cluster 1, the center point was this one. So we have written those center points. Similarly, cluster 2 center point was this one. So that means point number 5 was like cluster 1 center point, and 5 number 6 we considered as cluster 2 center point. Now we are going to see that whether the data point number 1, which means this particular data point number 1's distance, the smaller the distance, that means that data point is going to lie on that particular cluster. So if we are going to compare this one, the smaller distance is 4.47, which means the data point number 1 is the smaller distance to the point number 5, which is basically cluster 1's center point. So that means point number 1 is going to be lie the part of the cluster 1. Okay, so similarly, we have calculated the distance from the center point number 2 to center cluster number 1 center point and cluster 2 center point. The smaller is basically 3.61. So data point 2 is going to be lie the part of cluster 2. Similarly, from 3, we can see that the point number 3 is going to be part of cluster 2, and point number 4 is going to be part of cluster number 2. Okay. Now, what we are going to do in the next iteration, we will going to find out the new center points. Okay, so this was the first iteration center point which we initially assumed. Now we are going to find out the new center point. So how we can do that? we are going to use for the cluster number 1 center point. This is going to be the average of these two data points. Similarly, cluster 2's center point is going to be the average of these four data points. So how we can do that? That is with the help of this one. So that is cluster number 1's center point was point number 5 and 6. Okay, 1 and 5. And similarly cluster 2 center point was 2, 3, 4 and 6. Okay, so now we are going to find out the new center of these clusters. So that is going to be 7, this is point number 1, plus 9. Okay, that is cluster number 5, which means the second, this one. And because these are the two values, so that's why we are taking the average, which is 2. Okay, in order to calculate the average value. Okay, then 7 plus 3 plus 7 divided by 2. So we are going to get the new center point of the cluster 1. Similarly, cluster 2 having the 4 data points. So in order to calculate the center point, what we are going to do is 4 plus 2 plus 0 plus 6 divided by how many data points? 4. Okay, so that is the this one point, which is x-axis, and then for the y, this is going to be 5 plus 4 plus 1 plus 8 divided by 4. So this is the cluster 2 center point. Now again we are going to calculate the distance of every data point to these center points. So this is cluster number 1's center point, this is cluster 2's center point. Okay, so this is, we have calculated the distance from point 1 to cluster 1. Okay, that is cluster 1 center point. This is, we have calculated from the point number 1 to cluster 2's center point. So how we can do that? 7 minus 8 square, okay, then plus 3 minus 5 square, and take the square root. So this is the distance. Then 7 minus 3 square, then 3 minus 4.5 whole square, take the square root, that is the another distance. Okay, similarly for point number 2, this is 4 minus 8 square, then 5 minus 5 square, take the square root. This is the from point number 2 to cluster number 1's center points distance. Similarly, from number point to cluster 2's center point distance is this one. So we are going to calculate the distance from every data point to these two clusters. So this we have calculated for all the 6 data points. So based on this, again, the smaller the distance, so that particular data point is going to be like the part of that particular cluster. So that means point number 1 is going to be part of cluster number 1. Point number 2 is going to be part of the cluster number 2. Point number 3 is going to be part of the cluster number 2. Point 4 is going to be part of cluster number 2. Point 5 is going to be part of cluster number 1. And point 6 is going to be part of cluster number 6. Okay, so that is the new cluster. So which means now we have changed the values. So earlier in the first iteration, cluster 1 having the 2 values, now the cluster 1 having the 3 values. Over here cluster 2 having the 4 values, now the cluster 2 having the 3 values. So that means now we need to do another iteration. Okay, so for that we need to again find out the new center point. So cluster 1 center point is going to be the average of point number 1, point number 5, as well as point number 6. So this is basically 7 plus 9 plus 6 divided by 3. So this is going to be 3 plus 7 plus 8 divided by 3. Okay, so this is a new center point. Similarly 2, 3, 4. So this is basically 4 plus 2 plus 0 divided by 3. This is 5 plus 4 plus 1 divided by 3. This is the new center point. So I have written again the center point, right? Now again we are going to calculate from every data point to these two new clusters distance. So from point number 1 to cluster number 1, distance is going to be 7 minus this new center point 7.33, plus 3 minus 6 whole square, okay, and taking the square root. Then similarly from point number 1 to cluster 2's center point, the distance is 7 minus 2, and then 3 minus 3.33 square, taking the square root, that is this one. So again we are calculating from point number from point number 2 to cluster number 1 center point, cluster 2 center point. Similarly for the 3, similarly 4, 5, and 6. Okay, now if you can see that the point number 1 is going to be part of the cluster 1. Okay, point number 2 is going to be part of the cluster 2 because the distance of the point 2 to the cluster 2 center point is smaller. Similarly, point number 3 is part of cluster number 2. Point number 4 is going to be cluster number 2. 5 and 6 is going to be part of cluster number 1. So as you can see in the second and the third iteration, the points remains constant, which means there is no point movement from one cluster to another cluster. So the same allocation remains same. Okay, so that is indicating we should stop the algorithm, and this is the optimum, you can say, clustering. Okay, so this is indicating point number 1, 5, and 6 is going to be part of one cluster. Okay, so which is basically means, so this is going to be cluster 1. Okay, and this is going to be part of the cluster number 2. So this is how we can divide these data points into the two clusters. So I hope you got the idea how k-means clustering is going to be performed. So thank you so much. See you in the next video.